Hey guys, today we're going to solve LeetCode number 216, combination sum 3. We need to find all possible combinations of k numbers, distinct numbers, that add up to n. And we can only use the digits from 1 to 9. So we're going to solve this with a recursive algorithm. I'm not going to use any backtracking because I don't like it. And so as any recursive algorithm, I'm going to start with the base cases. So the base case of this algorithm is going to be if k is equal to 1, then the only possibility is the number n itself. Okay, so then we have two cases. What if n is greater than 9? So it's greater or equal to 10. In that case, we have no possibilities because we can only use numbers from 1 to 10. But if n is between 1 and 9, then we can return the only combinations of one number that add up to n is n itself. Okay, so that's what we're going to code up here. This is the base case. If k is 1, we check if n is greater or equal to 10. And if it is, we just return nothing, so an empty array, because there's no way, because n is greater than 10, so we can't use digits from 1 to 9 with k equaling 1. And what if n is actually less than 10? Then in that case, we can return a list with all of the possibilities to make up n with only one number, which is just the number itself. So remember that this needs to be a list of all of the possible combinations, and the only combination possible is the combination with only one element inside, which is n. So this is why this is an array of arrays. Okay. Okay, so this was our base case. Now we're going to do the recursion part. So first of all, we store our result in a variable, and we're going to return this result. And now this is a minor optimization. I'm going to define a variable up to, and this is the minimum between n divided by k and the digit 10. So why is this the case? Well, if n was like 100 and k is like 2, then we know that the minimum number that we're going to have in our sequence is 50. Okay, so we say since 50 can't be used, then I'm going to go with my for loop. I'm going to use a for loop now. I'm going to go up to the minimum between, in that case, that would have been 25 and 10. So if the minimum number that goes in our sequence is more than 10, then we go at most up to 10. Okay? Nice. So now we're going to solve the problem with a for loop. So we're going to go through all of the digits, and we're going to use them as a complement to our original target. So we're going to take our target and we're going to subtract from it the current digit. So this is the new target that we want to reach with k minus 1 numbers. Okay, so the first number that we've chosen is I. And now we're going to recursively ask, okay, what are all of the combinations of k minus 1 numbers that add up to n minus I? And those are going to be all of our candidates. Okay, so we take the same function and we say, okay, we have already one number. We've already chosen the first number, which is I. And so we're going to start with k minus 1 numbers. And the target is now n minus I, because I is our first choice. So that's the new target. And we need to start from I plus 1, because we don't want any duplicate numbers. Okay, so that's the reason for which I modified the function signature at the top here. We need that to avoid duplicate numbers. Perfect. Now what we do is we loop through all of these candidates that are combinations of k minus 1 elements and that add up to n minus I, so our new target. And what I do is I push all of them into the result array, but remember to add the first choice here. So what we do is we push into the candidate array our initial I choice, and then we push the candidate, the modified candidate, to our result array. So that's it. Since we are checking here if n is greater or equal to 10, we're never going to have any digits that are going to be greater than or equal to 10. So the time complexity of this algorithm is pretty hard to find. The time complexity analysis of this algorithm is pretty hard, but I believe it's close to the solution here, given here, which is done through backtracking, this is the time complexity of this algorithm. So I believe this is pretty close, and you know, the submission gives a good result here. So that's going to be it for me, and thank you for watching. Bye.